Welcome to another edition of Physics. In this case, we will be presenting fluid mechanics, and the problem is the next one. The problem says a large stone tank, open at the top and filled with water, develops a small hole in its side at a point 16 meters below the water level. If the rate of flow from the leak is 2.50 per 10 minus 3 meters over minute, determine A, the speed at which the water leaves the hole, and B, the diameter of the hole. Always, we have to sketch our problem. We have this tank and a little hole in here. We have a height of 16 meters between the hole and the upper part of the tank, and it says that the rate is 2.50 per 10 minus 3 meter over seconds. And we can assume that the pressures are the same because they are on the air, so they will be the pressure of the atmosphere, which is 1 atmosphere. For this case is the water. First we have to plan this. We have our pressure 1 plus the potential energy, in this case for the water, the kinetic energy, and same in here for the upper part and the lower part. We can assume that these two are the same, so we can eliminate them. We can also assume that this speed will be more or less zero because it's very slow, the rate in which this part will go down, and this part will be a little bit faster. So we can assume that part is zero, and in here the height will be zero, so this whole term can also go. In the end, we will only have this formula: half of the density per the velocity squared equals the density per gravity per the height. So we have to get the velocity, and here we have the formula, and we only substitute for the values required: the gravity, our height, and the 2 because it went from the medium, right? And this should give us a value of 16.71 meters per second. Following to the next part, we know that the rate of speed is area per velocity, and we already have the rate which the problem gives us, yet we have to do a little bit in here because we have it in minutes and we want it in seconds because that's how we have it in here. So for this we're just gonna make a simple transformation, and this will give us over 60 seconds. So we just divide the value over 60 seconds, and we try to get the area, so we divide by the velocity as well. That should give us a value of 2.35 per 10 minus 6 square meters. The area is of the circle is pi per squared radius. So we just get the r, and we substitute for the values, and this should give us the radius, which we will multiply by 2 because the diameter, we have to remember, is 2 times the radius. And this should give us a value of 1.73 per 10 minus 3 meters, or which would be the same 1.73 millimeters. And that's it. It's easy as that. See you next time.